Hello again. We're doing arithmetic series this time, and well, we did that before anyways, but we're going to do something that's a little bit more difficult for students to understand, to fathom, and that's basically sigma notation. What I mean by sigma notation is this, like Greek letter with a I equaling a number. It could be any variable equaling a number, but this variable and this variable are going to match, and it's got a number on top of here, and it's got something here, and students look at this and they just go, I'm done, I quit. But how many times do I hear that throughout the year, and then they just don't quit because, you just gotta keep trying. And then usually they don't find it that bad anyways. So they figure it out, and then 3 days later they forget it, they don't practice. So that's a heads up. If you don't practice it, you're gonna forget it. So I've got this problem in sigma notation, and we're gonna solve it, and then we're also gonna solve it using this, because it's basically the exact same thing, except it's just a different way to look at it. So what this is saying is, like, I'm gonna add all of you up. He doesn't actually say that, or this sigma, this letter doesn't say that, but what I'm going to do is I'm going to start at the number 3. I'm going to start plugging in values for this, little function, I guess, or actually series is probably the better word. I'm going to start at 3, and I'm going to go as many numbers as I can until I reach u. So in this case, I have to substitute in the number 3, then 4, then 5. If this number was an 8, I'd have to substitute in 3, 4, 5, 6, 7, 8. I'd have to keep going. Conversely, if this number were 2, I wouldn't start at 3. I'd go 2, 3, 4, 5, 6, 7, 8. But fortunately, all I got to do is substitute in the number 3, then the number 4, and then 5. I've got to go from here to there. So we're going to do it 2 different ways. Hopefully you'll see it. So I'm going to do that right here. I'm going to substitute in 3 first. So 2 times 3 is 6. 6 plus 1 is 7. So I substituted in 3. The next number I substitute in is 4. 2 times 4 is 8. 8 plus 1 is 9. Now I'm going to substitute in 5. 2 times 5 is 10. 10 plus 1 is 11. 11 plus 9 plus 7 is 27. Now it's my turn to make... It's my turn to verify if it's correct by using this one right here. So we're going to use the same formula, although students make a mistake here, and it's a notable mistake because, it makes sense that they would make the mistake without even knowing it. S sub n equals n, a1 plus an over 2. It seems hardly appropriate to add 3 numbers up using a formula, but it's just to verify. My a1 is 7, that's my first term. We're going to start with the easy ones first. My an is 11 over 2 s of equals, here's the trick behind it. A lot of people are going to say 5. They say, oh, there's 5 terms, that's how it works, 5 is the highest number. Actually, that's not true. When we did this, we found out that there were only 3 terms in the series, because we didn't start from 1. Well, technically, if we started from 1, it still wouldn't be 5. But we started from 3, and we went up to 5. Now, somebody says, oh, okay, so what I do is I take 5 minus 3, and I got 2. 2 should be my n. Like, no, actually not. If you want to figure out what your n is, the very simple way, the simplest way to do it, is take this number, subtract it by this number, whatever the answer is, add 1. So take 5 minus 3 and just add 1. And that comes out to 3. So 3 is my n. I'm going to figure out the sum of 3 terms. And people are saying, yeah, there's 3 terms. So I'm going to add up 3 of them together. So 7 plus 11 is 18. 18 divided by 2 is 9. 9 times 3 is 27. So we verified it using the exact same formula. That's pretty interesting. And pretty cool. What I want to do now is just do a really quick problem where instead of being given sigma notation or using a formula to figure out a series, I want to give you a series and see if you can figure out. But I actually would rather wait for the next tape because I think that's a little bit too much to absorb right now. So I'll do that on the next one, which I think will be really cool. And I think it'll answer a lot of questions when you see those type of problems because they are a little difficult. But for right now, have a good day. Goodbye.